Hi everyone, this is Miss Brubeck. In this set of notes, we are going to learn how to sketch and graph an exponential function, making a table of values. The first thing I want you to look at is this function, this f of x equals a times b to the power of x. This is what the basic exponential function looks like. It's similar to how we have y equals mx plus b for linear functions, but for an exponential function, we're going to rely on f of x equals a times b to the power of x. So first thing I want you to notice is this a. This a is our y-intercept. So that's the first thing you should notice, is that the a is always going to be our y-intercept. And then the b is going to be our growth or decay factor. And we'll talk about how to identify whether or not it's growth or decay. And an exponential function is an equation in which the variable is an exponent. So it's an equation in which the variable is an exponent. And as you see here, our variable is an exponent. So when we're making a table of values and we're making a graph, we'll plug in numbers into the exponent and get out our y value. We want to next focus on our b. So we're going to look at this b value right here. Look at that b value. We want to figure out what values of b makes the exponential graph increase and what values of b makes the exponential graph decrease. Any number greater than 1 will make the graph increase, and any number less than 1 will make the graph decrease. I think that's pretty easy to remember. Greater than 1, it increases. Less than 1, it decreases. And then what numbers can we not use for b? 0 and 1. We cannot use 0 and 1. And I'll show you what I mean by this. I'm going to go to the graphing calculator, and here we'll just use this function right here. My y-intercept is 2, so the a value is 2. That's my y-intercept right here. And then 1 over 3 is my b value. That's less than 1. This is what we call a decay. So this graph right here is decay. And if you zoom out, you can see like this is what it's going to look like. And it's going to go on forever this direction and forever in this direction. If we change it, let's just change it to a 4, greater than 1. Greater than 1, it's going to look like growth. And the growth looks like this. As the x values get larger, the y values get larger. Okay, as the x values get larger, the y values get larger. When you have decay, as the x values get larger, the y values get smaller, and that's decay. And then if we try to put a 1 in here, it's just going to make a linear function. That's not exponential. And if we put in a 0, that's not going to be exponential either. So those numbers do not work. We're then going to try and just identify some y-intercepts in growth and decay. So right here, this is our y-intercept. Our y-intercept is 5. And then our b value is 9. That is greater than 1, so it's going to be growth. In our next one, we have 2 over 3. Now that's actually our b value, because as we can see from the previous one, the b value always has the exponent. And so this 2 over 3 has the exponent. That's our b value. It's less than 1, so it's decay. And then our y-intercept is going to be 1. And if you're like, well, how's the y-intercept 1? Let me show you. There's an invisible 1 here. It's like 1 times 2 over 3 to the x. And you just don't have to write that 1. So that y-intercept is 1. For the next problem, 4 over 5 is our y-intercept. And then 2 is the b value, and that is greater than 1. So that is going to be growth. For the next problem, 11 is our y-intercept. And then 9 over 5 is the b value. 9 over 5 is actually greater than 1. And so that is going to also be growth. Next, we're going to sketch. So we're just going to sketch, not making a table of values. First, it wants us to find the y-intercept, and the y-intercept is 3. Then it wants us to find the growth factor. The growth factor is 5. And then it wants us to decide, is it growth or decay? Well, it is growth because the growth factor is greater than 1. So then to graph it, and all it wants us to do is sketch. We're just sketching. Our y-intercept is 3. So that will go right here. And then to sketch it, it's going to look like this. I'm going to do my best to make this look correct. One of my better graphs. So growth goes in this direction as the x values get larger, the y values get larger. The graph is never going to hit this x-axis. It's going to get really close. It's going to look like it touches it, but it never actually does. And I'll show you here, if I change this to a 3, change this to a 5, the graph looks like this. And like it looks like it hits the x-axis, but it actually never does. And if we keep going on this way, like you're going to see it never actually hits the x-axis. It gets really close, but never hits it. The next one, same idea. Our y-intercept is 2. Our growth factor is 1 over 3. And so since our growth factor is less than 1, that means it's going to be decay. And then to graph it, we'll make the 2, that's our y-intercept. And then it's going to go the opposite direction. And I'm going to try to make this look decent. Not bad. So you're just sketching it. That's all that we want you to do, is to understand, to know in your head, what is this going to look like. Next, we're going to actually make a table of values. So our y-intercept is 3. So whenever you have an x is 0, that is your y-intercept. So that's going to be our y-intercept right there. And we can actually, if you want to, go ahead and graph that. That's our y-intercept. The growth factor is 2, that's greater than 1, so it's going to show growth, but we actually want to find the values. So if we have f of x equals 3 times 2, and then if we raise it to the first power, we want to do the exponent first, because PEMDAS tells us we do exponents before we do multiplication. 2 to the first power is just 2, so we're going to have 3 times 2, which is just 6. So this number will be a 6. And then you can keep doing that. If I do that and I change the exponent then to a 2, we're going to have 2 to the second power, which is 4. And 3 times 4 is 12. So this value will be 12. And then you want to do the other numbers as well. If you want to, you can use your calculator. So it's 3 times 2 to the x. So if I make 3 times 2, and then to the power, you can click this button right here, where instead of like an exponent is just b, power of x, but change that x to a -1, that's going to get us 1.5. You also could write, you can write 1.5, you can write 3 over 2, that's also 1.5. And then we can do the same thing with -2, which I think it's 3 over 4. Yep, 0.75, which is the same thing as 3/4. And then we'll just plot our points. So 1 and 6, 2 and 12, -1 and 1.5, and -2 and 0.75. That's probably as close as I'm going to get. And then we do not want it to hit our x-axis. Didn't quite go through the points, but I'm going to call that good enough. That's going to work for this one. All right, then our next graph, same idea, but this time we have a 1/2. So we know our y-intercept is going to be 4. So that's our y-intercept. And if you want to go ahead and graph it, you can. Okay, and then we want to just plug things in. So if we plug in a 1 here, 4 times 1/2, that's going to be 2. And if you're not sure how I'm doing that, like we can always go to our calculator. So we have 4 times 1 over 2. And if you want to take that whole thing to the first power, oops, I messed up. It's 2, my bad. Oh no, that's what I said. I said 2. Oh, sorry guys. I said 2. So if you take that to the first power, you're going to get 2. If you take it to the second power, you're going to get 1. So, sorry, you probably think I'm crazy. Then if we take it to the negative first power, the answer is going to be 8. And if we take it to the second power, the answer is going to be, oh, it's not second power, it's negative 2. The answer is going to be 16. And then we can just graph those points. So 2, or sorry, 1 and 2, 2 and 1, negative 1 and 8, and negative 2 and 16. So I've plotted those points, and I'm going to try my hardest to make this graph look okay. Not bad. It's very challenging on the Jamboard. A lot easier with paper. All right, next one, we just have 2 to the second power. This one's going to be easy. 2 to the 0 power is just 1. 2 to the first power is just 2. 2 to the second power is 4. And then to the negative 1, you're going to have 1 over 2, and you can check that with your calculator. And to the negative 2, you're going to have 1 over 4. So feel free to check that with your calculator. I just can do it in my head. So I'm going to plot my points. Let's see, I've got 0 and 1, 1 and 2, 2 and 4, and then I'm going to need negative 1.5 and 1/4. It looks like it's going to touch the graph, but I promise you it never actually touches that x-axis. Oh, maybe my best one yet. So, it feels like an accomplishment when you make a good graph. All right, and then the last example, this time it's asking us to determine if the tables represent linear or exponential functions, and then write an equation to match each table. So I'll show you how we do this. First, you want to look at the pattern. So this pattern here, what is the pattern with the y values? We're looking at the y values and we're looking at a pattern. And then you also want to do the same thing here. You're going to look at the y values and find a pattern. So if you're looking at the one on the right, you're going to see that each time the numbers are subtracting by 4. So 14 minus 4 is 10, 10 minus 4 is 6, 6 minus 4 is 2, and it just keeps subtracting by 4. If you look at the next one, you're going to see it's multiplying by 2. So 1/2 times 2 is 1. 1 times 2 is 2. 2 times 2 is 4. And 4 times 2 is 8. So every time it's multiplying by 2. 8 times 2 is 16. 16 times 2 is 32. Okay? So if it's adding or subtracting by a number, it's going to be linear. Okay? If your y values are adding or subtracting by a number, it's going to be linear. And if they're multiplying or dividing by a number, it's going to be exponential. Okay, so if it's adding or subtracting by a number, it's going to be linear. So this one here is linear. If it is multiplying or dividing by a number, it's going to be exponential. And then if it's linear, we're going to use this here. Okay, so the -4, that is our slope. So our equation is going to be y equals, our m is going to be -4, that's our slope. We'll keep the x. And then the y-intercept is your value, like wherever, when x is 0, that y value is your y-intercept. So our y-intercept is going to be plus 2. And then for an exponential, we're going to use this function. We could have written f of x on the other side. It doesn't really matter. So we're going to have f of x. Our y-intercept is, again, where x is 0. So x is 0 right here. So that's our a value. So that equals 4. And then our b value is that it's multiplying by 2. So 2, and then we'll have it to the power of x. And that's how you do that.